So last week, we were talking about polynomials and factoring and quadratic equations. And a lot of you said that you wanted to maybe slow it down a bit and go over more about factoring and quadratics in particular this week. So that's what we're going to be doing. At the end of this class, I'm probably going to be quickly going through the other slides that I had planned, just in case you want to watch the YouTube video afterwards and try to understand it. And I would recommend that you do so. But for now, let's just kind of start from the very beginning and make sure that everybody has a good foundation. So let's start off with the basics of what is a polynomial and how do you factorize them. So let's start off with the definition of a variable. So a variable in math is something that replaces a number. So if I had, for example, the expression 3 plus 5, okay? And we all know this is equal to 8. And this is all well and good. But if I set a variable x, for example, is equal to 3, then that means that wherever I see a 3 in the equation I wrote, I can just as easily replace it with x, which means that this exact equation can also be written as x plus 5 is equal to 8. So the variable here would be x. And variables can be whatever you want them to be. For example, x in this case is 3, but x could be 5, or you could set another variable called a or b to be equal to another number. So let's try to look at this in the context of factorizing. So let's say, what is 2 plus 3 times 2 plus 4? Can anybody tell me what this is? Okay, so 2 plus 3 is 5. 2 plus 4 is 6. So this would be 5 times 6, which is equal to 30. Now, what if we had this exact same expression, except we replaced every single 2 with x, which means that this equation now becomes x plus 3 times x plus 4 is equal to 30. Now, we know that x is equal to 2, but let's, for a minute, ignore this, what we have here. And what if I told you to solve this equation for x? How would you guys go about solving it? Expanding it is definitely an option. Factoring the 30 in this case would actually be the better option, but there are cases where some methods are better than others. So let's say, for example, you just decided to expand it. So when you have two things in parentheses multiplied together and you want to expand it, you would have to multiply every single pair of terms together, which means that you would multiply x and x one time to give x squared, x and 4 one time to give 4x, 3 and x one time to give 3x, and 3 and 4 one time to give 12. So once you simplify this, you would get x squared plus 7x minus 18 is equal to 0. So then this would be your quadratic. And to try to solve for this, what you can do is you can try to, you could use the quadratic formula, which I would recommend you try not to use the quadratic formula if you have a quadratic with really easy coefficients. Like all of these coefficients right here are just integers. So if you use the quadratic formula, it's going to get really messy really quick because you have a lot of square roots and fractions. But obviously, we know that we can factor this quadratic. And can anybody give me a way to factor it? Which means writing it in the form of x plus some number m times x plus some other number n is equal to 0. So what would m and n be for these two to be equivalent? Okay, I see a really good idea right here. So someone's saying, let's just expand it. Let's pretend that x, m, and n, they're all just numbers. So let's try to expand it and see what we get. So since every single pair has to be multiplied together, if we pair x and x, that gives x squared. If we pair x and n, we get nx. If we pair m and x, we get mx. And if we pair m and n, we get mn. So this would be equal to 0. And we can simplify this expression because we have two terms here that both have an x. So nx plus mx would be m plus n times x plus mn. And this would be equal to 0. So we know that this equation that we got and this equation right here, they have to be equal. So if we directly compare terms, for example, there's an x squared here and there's an x squared here, so those match. There is an m plus nx here and then 7x here. And what that tells us is that in order for those terms to be equal, we must have m plus n is equal to 7. And we have a plus m times n here and a minus 18 here. So what that tells us here is that m times n has to equal minus 18. So can you guys solve the system of equations and tell me what m and n are? Okay, very good. I see some correct answers. So this here would give us m is equal to 9 and n is equal to -2. Alternatively, you could also say n is equal to 9 and m is equal to -2. These both work, and you'll discover that when you go back to plug them into x plus m times x plus n equals 0, they're identical. Because saying that x plus 9 times x minus 2 equals 0 is the same thing as saying x minus 2 times x plus 9. So they're basically the same thing. So once we plug m and n back into our factored form, x plus 9 times x plus -2, which is the same as x minus 2, equals 0. Now, can anybody tell me what the solutions for x are here? Well, in order for two things multiplied to be 0, at least one of them has to be 0. So if this one was 0, we get x equals to -9. And if this one was 0, we get x equals 2. And if you recall our original equation, we substituted 2 for x. And x equals 2 is one of our solutions. So we found the solution. Now, when we did this, we actually discovered another solution, which is x equals to -9. So in the original expression I gave you where I said this plus this times this plus this is equal to 30, -9 would have also worked instead of 2. So does anybody have any questions? Yes, this is actually the last class. I'll leave some time at the end to discuss about what you guys can do in the future, because we have a lot of other classes on our website that you can sign up for. But yes, this is our last class. Okay, so let's move on. Let's try to go into new content. This we discussed last time. This we did, this we did. So I think we're on here. So if you guys want some harder stuff, we can discuss this. So basically, Vieta's formulas are a way to tell you what the solutions to a quadratic or any polynomial are. So let's say I gave you the quadratic 2x squared plus 4x minus, let's say, 1 is equal to 0. So how many solutions does this equation have? Okay, good. So you can tell that it's a quadratic because its highest term is x squared. And because it's x squared, that means it has two solutions. So let's for example say that those two solutions, we can call them A and B, right? So just to be clear, a solution means that you can plug either A or B into this equation, and this equation would hold true. So for example, 2a squared plus 4a minus 1 is equal to 0. And that also means that 2b squared plus 4b minus 1 is equal to 0. So these equations both hold true. But let's get back on track here. What Vieta's formulas tells you is that there is actually a way to calculate a plus b and a way to calculate a times b. So I'm not sure if anybody knows this. If you do, can you tell me what a plus b and a times b are, given 2x squared plus 4x minus 1 is equal to 0? Okay, someone has the right idea. It's kind of confusing that we are using the variables a and b, but basically what the Vieta's formulas tells you is that the two roots added together is always going to be equal to negative of this term divided by this term, which means negative 4 divided by 2. And that's negative 2. And the two solutions multiplied together will give you positive of this term divided by this term. So positive negative 1 is still negative 1. So negative 1 divided by 2 is negative 1/2. So you'll notice that when you try to solve 2x squared plus 4x minus 1 and try to find those roots a and b, it's going to be really hard to do so unless you use quadratic formula. And there's no way to actually factor this in the integers because the solutions are actually pretty complex. But if you try to use the quadratic formula, you would get that a and b are negative b, which is negative 4, plus or minus the square root of 4 squared minus 4ac, which is the same as plus 4 times 2, all over 4. So the quadratic formula would tell you that a equals negative 4 minus 16 plus 4 times 2 is actually 24 over 4, and that b is equal to negative 4 plus root 24 divided by 4. That's what this plus or minus sign means. Now, what happens when you add this number to this number? What answer would you get? Well, let's try to add them together. So you have negative 4 minus the square root of 24 divided by 4 plus negative 4 plus the square root of 24 divided by 4. So because both of these fractions have the same denominator of 4, you can put them over the same number. So let's do that here. So what happens when you add these two together? Well, negative root 24 and positive root 24, they cancel out. And you have negative 4 minus 4, which is negative 8, divided by 4, which is negative 2. And you'll notice that negative 2 is right here. We already predicted that these two would add up to negative 2 with our cool trick. And if you tried to multiply these two big numbers too, you would end up getting negative 1/2, which I won't do because the math is kind of hard, but okay, so someone asked, why does that happen? So if you noticed in our last slide, there was kind of a hint that something like this would happen. Let's say, okay, let's, for example, go back to the m and n example. So let's clear the board. Okay, so basically, let's say that we have this quadratic in factored form, x minus a times x minus b is equal to 0, right? So what would be the roots of this quadratic? So what value of x could you plug in to make this true? So in order to make this true, either this term is 0 or this term is 0. And if x minus a is 0, that means that x is equal to positive a. And if x minus b is 0, that means that x equals positive b. So let's try to expand this entire thing. So can anybody expand this for me and tell me what you get? So remember, when you're expanding it, you're multiplying these two terms and then adding them to the product of these two terms, added to the product of these two, and then added to the product of these two. Okay, so when you multiply both x's, you're going to get x squared. And you're going to get minus ax minus bx plus a times b, since the negatives cancel out. And you can group these two terms together, and you'll get x squared minus a plus b times x plus ab. And don't forget that this was equal to 0. So what can you say about the two roots a and b? So remember our two roots from back here. So if I brought them down here and I told you what happens when you add them together, what would you tell me? Okay, so when you add them together, this is not equal to 2x because remember that either x minus a is 0 or x minus b is 0. It's impossible to have both equal to 0 at once, which means that these two, x equals a and x equals b, are not true at the same time. They are just two possible solutions that both work. You can either plug a into this whole thing and get 0, or you can plug b into this whole thing and get 0. So a plus b, the sum of the two solutions, you'll notice that our second term in this quadratic actually looks very similar. And in fact, it's equal to negative of this second term divided by the coefficient of the first term, since there is an invisible 1. And you also notice that the product of the two roots is equal to this last term divided by this invisible first term. So that's where you get Vieta's formulas from. So does everybody understand that? Vieta's formulas was the thing with most of these formulas is that they're usually named after the person who discovered them. Yes, this is the last class. So let's clear the screen here. Let's try some examples problems. So without solving this quadratic, what would the sum of the roots be? So we know that there are two numbers x such that if you plug them into x squared, minus 5x plus 9 is equal to 0, this would be true. So what happens when I add those two numbers together? So you would have to use Vieta's formulas for this. So what would happen if I summed up the roots? Well, yes, you could use the quadratic formula. You could say that the two roots are negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. But that's not really an efficient way to do this. You would notice that And the two roots, the plus or minus would cancel out. So if you have one root that's this, and another root that's the same thing except for minus, that when you add them together, the radicals cancel out. So you would just be left with 5/2 plus 5/2, which is equal to 5. And that's basically where Vieta's formulas comes from. But I want you guys to be comfortable with just simply looking at this and being able to tell. So remember that for quadratics, the sum of the roots is always going to be the negative of the second term. And the second term here is -5. So negative of -5 divided by the first term, which is 1. And so that's equal to 5. So the sum of the roots means that there are two roots to this equation. Like, for example, there is this number. And we already know from the quadratic formula, for example, one of these numbers could be 5 plus the square root of 25 minus 36 divided by 2. So this is just a number. So when you square this number and subtract 5 times this number, and then you add it to 9, that whole thing would give you 0. And there are two such numbers like this that give you 0 when you follow this step. So for those two numbers, what would happen if I summed them together, if I added them? And we just discovered here that that would be 5. So any questions here? Okay, so we're going to be moving on. And we just have a few minutes left, but I just wanted to show you guys these other problems. So what is the product of the roots of this cubic? And we didn't get a chance to talk about Vieta's formulas for polynomials other than quadratics, but it's kind of similar. You guys can read it up yourselves on Wikipedia or something. But the answer here is -27. The sum of the products of pairs of roots. Again, this is not really for quadratics, but it is true in general. This would be 4. And there's factorization tricks here. I'm just briefly running through these so that you guys can watch the YouTube video later. So this is the binomial theorem. You can expand anything of the form a plus b all raised to the nth power. Okay, so this is a difference of squares. So in general, x squared minus y squared can be written as x plus y times x minus y, right? And this is what's called Simon's favorite factoring trick. And it's called that because some guy on the art of problem solving called Simon came up with this trick. And the way you would factorize this is x minus 5 times y minus 4. And if you expand this, you'll actually find that it equals xy minus 4x minus 5y plus 20. So this is something you would use the binomial theorem for. And you get x cubed plus 3x squared y plus 3xy squared plus y cubed. And you'll notice that the coefficients 1, 3, 3, 1, the numbers in the beginning of each term, are actually a row in Pascal's triangle. So that's something interesting. There's challenge problems here. I'm not going to go over these, but if you have time, you can look at these. Okay, so that's all. Thank you everyone for attending this beginner contest math course. And today was our last class, but we do have other math classes on our website at alphademic.org. And we actually just came out with an intermediate contest math course, which is slightly harder than this. It's meant for problems around the AMC 10 level. So if you found this class slightly easy, you can try that out. The recordings for all of these classes will be available on our YouTube channel. And you can get to our YouTube channel by going to youtube.com/Alphademic Learning. And please consider subscribing so that you can receive updates whenever we post a new video. On the contact page of our website, you can also, if you have either a Facebook, an Instagram, or a Twitter account, you can follow us there, as well as our email list. And make sure you tell your friends about us so we can try to reach more people and teach a lot more students in the future. And thank you for joining us. And have a great summer, guys.